Have you ever looked up at the night sky, spotted that faint red dot and wondered, could humans really live there one day? Could we take a cold, barren world like Mars and turn it into a second Earth? It sounds like science fiction, but for decades, scientists, engineers, and dreamers have explored this bold idea. It's called terraforming, modifying an alien world to make it more Earth-like. But is terraforming Mars actually possible? Could we walk in a Martian forest or swim in a Martian lake someday? Welcome to the adventure of transforming the red planet into a green world. Before diving into the how, let's talk about the why. Earth won't last forever. Climate change, overpopulation, asteroid threats. These are not sci-fi horror stories. They're real challenges. Exploring space is not just about curiosity. It could be essential for human survival. Mars is the most Earth-like planet in our solar system. It has day-night cycles similar to ours, seasons and water ice. It's not perfect, but it's a start. And let's face it, colonizing another planet is the ultimate adventure. Imagine being part of the generation that didn't just dream about new worlds, but built one. To terraform Mars, we first need to understand what we're working with. Mars is cold, really cold. The average temperature is -63 degrees Celsius, -81 degrees Fahrenheit. Its atmosphere is 100 times thinner than Earth's and made mostly of carbon dioxide. No breathable oxygen, no liquid water on the surface. And, perhaps worst of all, it has no global magnetic field to protect it from radiation. Sounds bleak, right? But it's not hopeless. In fact, some of these features are surprisingly useful. Terraforming Mars isn't a single-step process. It's a long journey that could take centuries, involving multiple phases. Step 1. Heat things up. We need to raise the average temperature so that water can exist in liquid form. There are several ideas on the table: greenhouse gases, pump gases like CO2, methane, or even engineered super greenhouse gases into the atmosphere to trap heat. Orbital mirrors. Launch massive mirrors into orbit to reflect sunlight onto the surface. Nuclear explosions. Yes, some have seriously proposed detonating nuclear bombs at the poles to release trapped CO2 and kickstart warming. Elon Musk famously tweeted about it. As the planet warms, CO2 trapped in the soil and ice caps could be released, creating a denser atmosphere. A thicker atmosphere could help retain heat and protect against solar radiation. But it's still not breathable. This is one of the toughest challenges. Without a magnetic field, solar winds could strip away any atmosphere we build. Some scientists have proposed placing a giant magnetic shield between Mars and the Sun at the L1 Lagrange point. It's ambitious, but possibly doable. With a warmer planet and a thicker atmosphere, we could start producing oxygen, photosynthetic microbes, genetically engineered bacteria and algae could start converting CO2 into oxygen. Plants. Eventually, we could plant hardy vegetation to help with the process. But even at maximum effort, creating a breathable atmosphere could take thousands of years. Let's jump forward in time. Picture it. Green valleys, rivers flowing through terraformed Martian plains, domed cities where humans live and work. Outside the domes, hardy earth plants sway in the breeze under an amber sky. Schools, farms, playgrounds, all on a planet that once seemed lifeless. This isn't just science fiction anymore. With enough time, innovation, and international cooperation, it could become reality. Of course, it's not all sunshine and alien roses. Terraforming Mars comes with enormous challenges. Time. Even with the best technology, the process could take hundreds or thousands of years. Cost. Estimates suggest trillions of dollars. This would require unprecedented global collaboration. Ethical questions. Do we have the right to change another planet's environment? What if microbial life exists on Mars already? Should we preserve it instead? These are not questions to take lightly. They deserve discussion and debate. NASA, SpaceX, and other organizations are already working on technologies that could be early steps toward terraforming. Mars rovers, analyzing soil and climate. InSight mission, studying the planet's interior. MOXIE, on Perseverance rover, successfully created oxygen from Mars's CO2 atmosphere. SpaceX's Starship, designed for interplanetary travel. These aren't terraforming missions per se, but they lay the groundwork for understanding and shaping Mars's future. Interestingly, Earth itself provides a kind of reverse experiment. We're currently warming our own planet, unintentionally. Terraforming Mars might help us understand how to fix Earth. Think of it as learning how to build so we can learn how to repair. Plus, building sustainable systems on Mars could lead to new technologies for clean energy, closed-loop agriculture, and efficient waste management back here on Earth. Is terraforming Mars possible? Maybe. Is it hard? Absolutely. Is it worth it? That's up to us. Colonizing Mars could be humanity's greatest achievement, a unifying project that brings together nations, disciplines, and generations. It's a journey that may take centuries, but it begins with the first step. And that step might be taken by someone reading this today. So next time you look up at the night sky and see that faint red dot, remember, it might not stay red forever. One day it could be green. The red planet challenges us. It dares us to dream, to build, to reach beyond the cradle of Earth. Terraforming it will require courage, brilliance, and patience. But if there's one thing history has shown us, it's that humans are capable of turning the impossible into reality. Mars is waiting. Are we ready?